What is up, Algebra 1? This is lesson 73 and 82. Our objective is, how do you solve compound inequalities? First of all, what is a compound? Well, compound is a mixture of at least two different ingredients or parts. So if we're talking about a compound here in mathematics, we're going to be talking about compound inequalities. So compound inequalities is where we have two or more inequalities that both restrict the same variable. So we have two different basic types of compounds. We have ones that are AND, which we call conjunctions, or we have ORs, which we call disjunctions. So AND would be something like this, where x is less than 5 and x is greater than 0, greater than or equal to 0. You can also write this conjunction like this. And so notice this x is restricted smaller than 5, but also it has to be bigger than or equal to 0. So it's all these numbers between 0 and 5. So this is what we call an AND. An OR these disjunctions, is where maybe x is bigger than 5 or x is less than or equal to 0. So up here, above 5 or below 0. Now it is possible to have no solutions, like if it were to say AND in here instead of OR, it's impossible to have a number bigger than 5 and smaller than 0, right? And it is possible to maybe have something like this where you have two restrictions that actually both go in the same direction, and we'll see some of those here as we work through this. Alright, so here is to solve each compound inequality and graph its solutions. So whenever you have a compound inequality like this, we're going to solve it just like you would normally, but notice we kind of have 3 parts. So instead of doing it to quote-unquote both sides, we're going to do it to all 3 sides. So here I'm going to multiply everything by 7. So I'm going to have negative 7 is less than v, because remember those go to 1, which is less than or equal to 0. And now this is down, I don't have anything else with that v, so I can put a closed circle right here on 0. And at negative 7, I can put an open circle. And I'm talking about all these numbers in between. And since I'm working with different colors, I do it like this. You can, if you want to on yours, do it like this. Probably look neater anyways. Let's look at number 2. Notice I have 2 inequalities, so I need to solve this one, and I need to solve this one. Solve the one on the left, I'm going to add 4, so I'm going to end up with m is less than or equal to 4, because I added 4 here and added 4 here. The one on the right, I'm going to also add 4, because it's a negative 4. So I end up with m is greater than negative 1. So let's graph both of these. The first one here is 4. And it is going to the left, right? M's are smaller than this, so I need to go that way. So anything smaller than that, 4, will be fine. This one on the right says open circle here, and then I'm going to the right. So M's are bigger than that, so anything to the right of that. Now notice also that this is an OR, not an AND. If it was an AND, I would have to satisfy both of these, and it would just be between here. But since it's an OR, it says if I'm smaller than this, then it works, and if I'm bigger than this, then it works. So notice it's actually the whole entire number line. So I'm going to say all real numbers. And then if you wanted to color it, I've kind of made a mess of all this up here. You would just color the entire number line. So kind of like put an arrow on this way, put an arrow going this way, and shade in everything in between. Number 3, we have another OR. So I'm going to solve this one on the left by multiplying both sides by 3. So end up with b is greater than negative 3. The one on the right, I'm going to add 5 to both sides. So end up with b is less than negative 4. So negative 3, open circle, and b is bigger than that, so it's going to the right. And this one says negative 4 here. And b's are smaller than that, so going to the left. So that'd be the graph of that, because this is or, so as long as either one of those are true, that's fine. Pretty much the only numbers you couldn't pick are numbers here between negative 3 and negative 4. One more on the slide here. Let's divide this by negative 5. Whoop, 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 whoop. Remember, if you divide by a negative number, or if you multiply by a negative number, you must flip the sign. So this is going to be k is greater than or equal to negative 1. Or if I subtract 5 here, subtract 5 here, k is going to be greater than negative 4. So let's see here. K, negative 1 is going to be solid, going to the right. Here is open circle at negative 4, and k is bigger than that, so going to the right. So kind of notice it's redundant, right? If I say the number I'm picking is bigger than negative 4, doesn't it already imply, or if I say it's this, it's already implied that it's that. So only I have to graph this 1, negative 4 going to the right. So this one here, I've already said that it's bigger than that with this one. Okay? So just an open circle here, negative 4 going to the right. 3 more, then I turn you loose on your homework. And I've done quite a few of them from your homework problem, so you should be happy. Okay. So here we go. This is an and, so both of these have to be true. It's an and. So here I'm going to add 6, so n is bigger than negative 4. Multiply here both sides by 8. So I get n is less than or equal to 8. So both of these must be true. So here's a closed circle on 8. This is going to be going to the left. Open circle on negative 4. And it's going to the right. And yes, that's possible. We'll have something between those two. So I'm going to color just like that. Number 8. I'm going to multiply everything by 6. So I'm going to end up with 6 is less than or equal to x, which is less than or equal to 0. Now, I don't know if you noticed this or not. So let's look at this part right here. X is bigger than or equal to 6. Okay, so we're talking about numbers up here. But at the same time, x must be smaller than 0. So I need something up here that's also down here, because this is like an and, it has to be true for both of these. Since there's no place where that overlaps, there's no place where this is smaller than this, I'm going to say no solutions. And number 17. Let's see here. I'm going to subtract 10 from all 3 sides, so I end up with negative 24 less than or equal to 8v, which is less than or equal to 16. Dividing everything by 8. Let's see here, this is going to be v, this is going to be 2, this is going to be negative 3. And this one does work because at negative 3 I can do a closed circle. At positive 2 would be a closed circle. And there are, v can't be bigger than negative 3 and smaller than 2 at the same time. Alright, so your homework is a worksheet. If you haven't picked it up already, you should. Good luck.